In this video, we'll be learning about the equilibrium of a rigid object. So we know that a single unbalanced force acting on a rigid object produces translational motion. Again, the force acting on a rigid object that is fixed at any point may produce a turning moment, means it can produce rotational motion. A rigid object or a system of particles is said to be in equilibrium state if its translational as well as rotational motion remains unaffected when the external forces are acting on it. So we can say that equilibrium can be of following two types. Translational equilibrium means when a rigid object it is said to be in translational equilibrium if it either remains at rest or continue to move with a constant velocity, means if the object is not moving at all and if it is moving with a constant velocity, means its speed or velocity is not increasing or decreasing. So, for translational equilibrium of a rigid object, the net force acting on the object must be zero. It means that the vector sum of all the forces acting on the object must be zero. It's not like that the force is not there, that no force is acting on an object. It may be like 3 or 4 forces are acting on the object, but the vector sum of all the forces must be zero. So we can say that for translational equilibrium, summation of F is 0, means the vector sum of all forces is 0. So if a rigid object maintains its rest position under the action of forces acting on it, it is said to be in a state of static equilibrium. But if a rigid object maintains its state of uniform linear motion, means if it is moving with a constant velocity in a straight line, then under that thing we can say it is said to be in the state of dynamic equilibrium. Dynamic means it is moving. Next type is, here we can see the examples. A book placed on the table, a balanced beam balance, baby sleeping in a child's swing, and a girl sitting on a chair are example of static translational equilibrium, means here the object are at rest. Then a train or an automobile running with a constant velocity, an aeroplane flying high at a constant velocity, raindrops falling vertically downwards with constant velocity, a floating body, etc. All these are the examples of dynamic translational equilibrium. Then, if we talk about rotational equilibrium, in rotational equilibrium, we can say that a rigid object is said to be in rotational equilibrium if it maintains its state of uniform rotational motion or zero rotational motion. So, for rotational equilibrium of a rigid object, the net torque, means the moment of the force acting on the object, must be zero. It means that an object will be in rotational equilibrium if vector sum of all the turning moments due to various forces acting on it is 0. Again, same condition, it's not like the forces will be 0, but the vector sum of all the turning moments will be 0. So we can say that for rotational equilibrium, summation of tau means the torque acting on an object, will be 0. We can see some examples: a fan rotating at a constant speed, the earth's rotation about its own axis, motion of minutes and hour hands of a running wall clock, etc. They are all the examples of rotational equilibrium. We can say that in all these examples, net torque, means turning moment acting on the object, is 0. So I hope you have understood it. Thank you.